Hi, this is Sri Lakshmi Pai with AWS. Today we are going to talk about authenticating a .NET Core web application using Amazon Cognito. In this video, we'll be covering following topics: Amazon Cognito, serverless computing on AWS, and a demo of calendar web application. So external facing web applications nearly always need some kind of authentication and to store and manage users. Developers typically rely on a custom user database solution to store and manage users. This approach usually leads to challenges with scaling to a large number of users. With Amazon Cognito, developers can offload the storage, management, and authentication of users to a managed service that can scale up to millions of users. Developers can spend their time creating great applications and let Amazon Cognito handle authentication. So the key benefits of Amazon Cognito are: it is a secure and scalable user directory. Amazon Cognito user pools provide secure user directory that scales to hundreds of millions of users. As a fully managed service, user pools are easy to set up without any worries about standing up server infrastructure. With Amazon Cognito, your users can sign through social identity providers such as Google, Facebook, and Azure, through enterprise identity providers such as Microsoft AD via SAML. Amazon Cognito User Pool is a standard-based identity provider and supports identity and access management standards such as OAuth 2.0, SAML 2.0, and OpenID Connect. Amazon Cognito also supports multi-factor authentication and encryption of data at rest and in transit. And Amazon Cognito is also HIPAA eligible and PCI, DSS, and SOC compliant. Amazon Cognito provides solutions to control access to backend resources from your app. You can define roles and map users to different roles. Your app can access only the resources that are authorized for each other. With a built-in UI and easy configuration for federating identity providers, you can integrate Amazon Cognito to add user sign-in, sign-up, and access control to your app in minutes. You can customize the UI to put your company branding front and center for all user interactions. So now we are familiar with Amazon Cognito, let's move to serverless computing on Lambda. So AWS Lambda lets you run code without provisioning or managing servers. You pay only for the compute time you consume. There is no charge when your code is not running. With AWS Lambda, you can run code for virtually any type of application or backend service, all with zero administration. Just upload your code and Lambda takes care of everything required to run and scale your code with high availability. So the key benefits of Lambda are: AWS Lambda automatically runs your code without requiring you to provision or manage servers. Just write the code and upload it to the Lambda. AWS Lambda automatically scales your application by running code in response to each trigger. Your code runs in parallel and processes each trigger individually, scaling precisely with the size of the workload. With AWS Lambda, you're charged only for every 100 milliseconds your code executes and the number of times your code is triggered. You don't pay anything when your code is not running. So with these benefits, it actually makes sense to combine your AWS Lambda with AWS Cognito to authenticate users. To demonstrate how we can leverage AWS Cognito to authenticate an serverless .NET application, we'll build the following in this video: an Amazon Cognito user pool to authenticate, store, and manage users. We'll be configuring and deploying an ASP.NET Core web application that will be hosted in AWS Lambda and fronted by API Gateway to call these functions. A client-side script will authenticate user against Cognito and give back a JSON web token, which it will then pass in the HTTP authorization header to our web API methods that require authorization. So this is how the architecture of our calendar web app looks like. So user signs in into our application. and the Amazon Cognito authenticates the user and gives back a JSON Web Token, which is then sent back by the user in the HTTP authorization header to the API gateway, which will call your Lambda functions, that is get, put, and post. So the get event will get you back all the events, and the post function will help you create and edit events. So this is just a simple web application which will create and edit events in the application and uses Amazon Cognito for the user to authenticate against the application. So let's start building. Open the AWS console and navigate to the Amazon Cognito service. You can either choose it from your recently visited service or just search in the search bar. And click on it. Now let's create a user pool. Click on Manage User Pools. In this page, click on Create a User Pool. Add the user pool name. We'll add it as Calendar Web App User Pool. So let's review the defaults. So the pool name, the required attributes is email, minimum password strength is 8, the password policy is uppercase, lowercase, special characters and number, and you can edit it if you want to add more or remove certain restrictions. User sign up allowed. You can either let only administrators add users or allow users to sign up themselves. If you want multi-factor authentication, you can enable it here. Let's add an app client. This is an application client which will help us connect to our .NET application. Calendar Web App Client. Make sure you uncheck Generate Client Secret because the JavaScript client which we are going to use to authenticate users does not support client secrets, as the source code can be seen on the browser. Once you create the app client, go to the pool details and click on Create Pool. So this creates your user pool. Make sure you copy this pool ID and save it in a text editor. Next, let's go to the app clients. And save the app client ID in a text editor. We'll need these details in our application. Now let's create some users and add them to the group. Test user. Create a temporary password. And when you first time log in into the application, user will be required to change this password. I don't want a phone number. I'm just going to enter the email ID. So now the user has been created. Let's create a group. I'm creating this group because this group will allow users to create the calendar events in the application. If you're not part of this group, they'll not be allowed to create any applications. Once I create the group, let me add users. The user has been added to the group. So this is how you create a Cognito user pool and add users and groups to the user pool. And you also create an application client to connect it to your application built either in .NET or any other programming languages you choose to. Let's now create a .NET Serverless application and then host it on AWS Lambda. Before we create a project, make sure you have AWS Toolkit installed on your Visual Studio. This will give you options to create AWS project templates and also deploy onto AWS services from Visual Studio. Click on New, Project, select AWS Service Application, and type the name Calendar Web App. Click on OK. Select ASP.NET Core Web API, then click on Finish. This will generate skeleton code for our project and also a CloudFormation template that will deploy the solution. This blueprint relies on the Amazon Lambda ASP.NET Core Server NuGet package to translate calls between API Gateway and the ASP.NET Core framework. The ASP.NET Core Web API Blueprint project template creates two entry point classes, Lambda entry point.cs and local entry point.cs. The local entry point.cs class is used when running your local environment and leverages Kestrel, the ASP.NET Core Web Server. This makes it really easy to test our project locally before deploying it. The Lambda entry point relies on API Gateway. Now let's create a custom authorization handler class. Right-click and add a class. Add the authorization reference. This custom handler just checks to see if the Cognito group is equal to whatever group you specify in the authorization policy. Let's add another class called Cognito Authorization Handler. We have added two classes, Cognito Group Authorization Handler and Cognito Group Authorization Requirement for custom handler. This custom handler just checks to see if the Cognito group is equal to whatever group you specify in the authorization policy. In the next step, we'll be adding authorization policy. Let's jump back to the startup.cs file and add the code. Let us now update the configure services method to connect to Amazon Cognito and also to add the authorization policy. As you can see in this method, we are checking if the user is part of the in-calendar right group by adding a policy. Now let's update the audience and authority property here. Let's take the value which we copied when we created the user pool, the user pool ID over here, and also copy the region name here. So this will create your authority property. Next, let's copy the application client ID. Paste it here. For production app, you could pass authority and audience values as environment variables at deploy time. Then read the values with environment.getEnvironment variable. For testing locally without having to worry about certificates, set require HTTPS metadata equal to false. For production application, require HTTPS metadata should be set to true so that the JWT token is sent only over HTTPS. The JWT bearer middleware validates the JWT's digital signature, checks the expiration, and does other checks, then creates a claims principal for the current user. The configure services class is responsible for doing following: registers your policy and adds a singleton of the handler class, configures the JWT authentication options. Next, let's update the configure method. This code enables app to serve static files like HTML, CSS, and JavaScript, as well as default files, so you don't have to specify index.html in the URL of the main page. Now let's create calendar, event, and event controller classes. This class has all the properties that we need to create and edit an event. Now let's create an events controller class. In events controller class, we have implemented get method to get all the calendar events, post method to add calendar events, and put method to edit already existing events. As you can see, we have decorated all these methods with authorize attribute, and it is a custom attribute to authorize our policy and checks if the user is part of in-calendar writer group. To keep things really simple for this walkthrough, you will just be storing events in a static collection in the controller. In a real application, you would persist them somewhere durable and share between different Lambda invocations like Amazon DynamoDB, a serverless NoSQL database. Lambda functions will be unloaded after about 5 minutes of non-use, so any events you add will disappear when that happens. The test event created in the constructor is used to demonstrate the ability to see events when not authenticated. So now let's add the UI for this application. ASP.NET Core uses the folder www.root as the root web directory by default, so let's add a new folder www.root. As you can see, this folder has changed the icon just to show that it is the root web app directory. Let's add all the UI files required for this web application. I have already created these files. I'm just going to add them to this application. We are using full calendar event.js to create and edit the calendar UI. In index.html, we have all the UI required for this app and also the JavaScript which will help us connect to AWS Cognito. So let's configure some values here. As you can see, we have to update the user pool ID and the app client ID. Since the demo app is very simple, JavaScript used to authenticate and create edit events is embedded inline in the index.html. On document.ready, the source for events in full calendar is set to API/events. Full calendar passes the start and end arguments. For test purposes, we have used login button to authenticate the user. During authentication, we call the authenticate method, which handles the on success, on failure, and new password required events. On first login, the new password required event is triggered and prompts user to enter the new password, and then they will have to log in with the new password. This will change the user's status in Cognito from forced change password to confirm. To keep things simple in this walkthrough, a token refresh strategy is not implemented. When the JWAT token expires, like after 1 hour, subsequent put or post calls will fail with 401 unauthorized response. In this walkthrough, we are implementing the UI and authentication flow ourselves in HTML and JavaScript. Cognito can actually host the login from itself and handle the change password flow and other scenarios as well. You can even customize the UI with your own logo and CSS. JavaScript here is to demo the minimum Cognito functionality to support a custom authorization handler in ASP.NET Core. Let's test this application locally. Enter the user which you created in the Cognito user pool. As this is the first time login, you can see we are prompted to add the new password. Enter a new password. And click on change. Password has been changed. So let's log in with a new password. As you can see, a test event has been added, which we added in our event controller class. Let's click on any other date and create an event. Test demo event has been added. So this app is here to demo the minimum Cognito functionality to support a custom authorization handler in ASP.NET Core. So now that we have tested this application locally, let's deploy this application onto AWS Lambda. Before doing that, let's add getResources event to our CloudFormation template. Under ASP.NET Core function, under events, we'll add getResources event. This will get the resources, all the events. Save this template. Deploy this project onto AWS Lambda. Right-click on the project and select Publish to AWS Lambda. You can see the region is selected as US West, but we created our app pool in Seoul. So let's select Seoul. Add a stack name. And a bucket name, and click on Publish. Using CloudFormation Stack, our Lambda functions are deployed onto our AWS account. Let's wait for the status to change into complete. Once it's completed, we can test our application. Now that the status is Create Complete, let's browse the AWS Serverless URL. Add a /. I'm going to log in using the test user which we created. Now that the user is logged in, let's try to create an event. The event has been created. So this shows that whenever a user who's part of Calendar Writer group logs in, he's able to create an event. To test if the user who's not part of the Calendar event group is able to create event or not, let's try to log in using a different user. Let's go to Cognito user pools. I have created a user test user 1 who is not part of the Calendar Writer group. I'm going to log in using test user 1 to check if he's able to create the events or not. Test user 1, the password. I've already confirmed password, so it's directly going to log in into the application. So as you can see, you do not have permission to save events messages displayed to the test user 1. So this is because we have decorated each of our API events with an authorization policy which allows only users who are present in Calendar Writer group to create events. So to wrap things up, in this demo we created a ASP.NET Core single page application and connected it to Cognito user pool to authenticate users using custom authorization handler. Hosting an entire website in Lambda is a fun approach, but using Lambda to serve static content isn't optimal. Lambda cold starts mean the index.html page will be slow to load for users whenever the website hasn't been visited for more than a few minutes. To address that, you should move static content, HTML, CSS, and JavaScript to an Amazon S3 bucket and enable static web hosting. You can also use your own domain for both the API gateway and for the S3 bucket setting the domain root yourdomain.com or www.yourdomain.com to point to the S3 bucket and a CNAME like api.yourdomain.com pointing at your API gateway. That way your web page can load immediately and show an updating message to the users if the API is responding slowly. If you have an existing ASP.NET Web API project that you would like to migrate to run in AWS Lambda rather than starting from a new project template, check out Norm Johansson's blog, Deploy an Existing ASP.NET Core Web API to AWS Lambda. I hope you enjoyed watching this video. For more videos like this, visit tinyurl.com/AWS S4 Microsoft Workloads. Thank you.